Hello everybody. We will start doing 2.7 numerical approximations Euler method. I advise you to watch the video and just go over. So sadly, a lot of, just as you know, just I used to say all the time, uh, most of equations cannot be solved, and we just have a few methods. Hopefully, one of you will solve it one time. Today our lecture will be on Euler method, how you can find the solution when we have an equation in form of y prime is equal to fx. We will have a function, two variable x and y, and with the initial value y is equal to y naught is equal to xy naught. So from here, our goal is to approximate the solution. We did define the unicity of the solution or the stuff, but one thing we have to set up is to fix a step side. Let's fix first the step side. Let's fix the step side. Let's call it h. Okay, we call the step side h, and let h be x1 minus x0, or you can just say as x1 is equal to x0 h, and x2 is equal to x naught plus, sorry, here is x naught, please, plus 2h. Okay, so you can write down like this, or you can also write down like this if you want. Okay, you can also write down like this. X2 is x1 plus h. This means if you substitute by x1, you will have x naught plus h, and that's why you have x naught is equal to x2h. You got it? I can write it down directly or just leave it like that. Also, it's the same thing if you have x3 is equal to x2 plus h, which is x naught plus 2h plus h, which is x naught is equal to 3h. You got it? We just need this one. We just need this one and this one. Just make sure. I just prove it. How did you get from here to here? Okay, that's the way you have to prove it. Also, if you keep going now until you reach xn is equal to, then for xn is equal to x naught plus nh. Okay, so those are the step side. So now we will approximate yx naught. Okay, now yxn. Let's approximate yx naught. Okay, if you have to approximate yx naught, how can you do that? So remember the graph. Remember if you go for example from x naught, y naught, yn, xn and yn points to xn plus 1 and yn plus 1. Suppose we go to that point. Okay, on the graph of solution of yxn. Okay, suppose we, so now let's think about those 2 points and we draw the straight line and we try to approximate by using the tangent line approximation. Okay. Remember, we are using now the tangent line. Use the tangent line approximation. If you use the tangent line approximation from those points, let me point out from these points, if you use the tangent line approximation, go back to the approximation we did on calculus 2, I believe so. We will end up having yn plus 1 is approximatively equal to y naught, yx, yn plus yn prime of x naught. You can just write down here y, okay? And then parentheses, xn plus 1 minus yn. Remember, those was a slap. This one was a slap. Like if you have a y is equal to m, parentheses x minus x naught, right? And then plus y naught. And y minus y naught is equal to m, parentheses x minus x naught, xn. This is the same thing as here, but it's just now we are using the approximation. Okay, we approximate now. Okay, let's go from here. And remember, y prime we are dealing with here. We are dealing with y prime is equal to fxy, a function of x and y. So y prime of x naught. So y prime of x naught is nothing than fx naught y naught, yn. Okay? You can substitute from here. And remember x, remember also h is just x naught, xn plus 1 minus xn. That's h. So if you substitute here, we will end up having yn plus 1 is approximatively equal to yn plus yn prime xn plus 1 minus xn. So now here is just yn is equal to plus y prime. Remember here y prime is this one, is fxn yn. And this one, the difference is just h times h, okay? Times h. So now here is our approximation. xn plus 1 is approximatively equal to yn plus f xn yn h. Okay. So we are here, and that's all we have to use to approximate. Because of the approximation error, that point, you have to remember also something, that point, this point, because of the approximation error, that point is not exactly lying on the solution of the curve. That's why we have to approximate, okay? I repeat, because of the approximation error, this point, this one, that point, is not exactly lying on the solution, okay, of the curve. Like the curve of y is equal to yxn, okay, that's the curve, okay. That's all you have to remember, and that's all you have to know geometrically to be able to do some exercise. Let me just give you one simple example how you can use those when you try to approximate. Just make sure you go over and check the proof. So for example, let's try to approximate that solution. You have y prime is equal to x plus y to the third, and you have the initial value, which is y0 is equal to 1. Okay. So here you can tell here we have x naught is equal to 0, and then y naught is equal to 1. You can tell from here because the 0 is the x naught and the 1 is just y naught. Okay, so now let's use that formula. So we have y n plus 1 is approximatively, okay, or you can just say equal. That's fine. That's fine if you say equal. Okay, that's fine if you say equal. Yn plus f x n y n parenthesis h. It's this one. I just use this one. Okay, so we have this one. So we can use it. You can use it. So if n, let's see if n is equal to 0. If n is equal to 0, we have y1 is equal to y naught plus fx naught y naught h. Okay. If we choose h be 0.05, for example, okay? H is always given, by the way. Okay, h is always given. So now what we should get, we will get, remember x1 is equal to x naught plus h. So since x naught is equal to 0, okay, since this one is equal to 0, and then we end up having 0 plus 0.05, which is 0.05. Then x1 is equal to 0.05. That's x1. Okay, that's x1. So x1 now is equal to 0.05. Okay. So now how can we calculate now y1? Y1 is equal to y naught plus f0. Okay, because x naught equals 0. And y naught is equal to, where is y naught? Y naught is equal to 1. And then h is equal to 0.05. Okay. So here we have y naught is equal to 1. Why? Because y naught is right here, is equal to 1. Okay, that's y naught. Okay. So we have 1 plus f naught f1. So we have to go back, check the f function, and remember the f function is this one. This is the f function. This is fxyy. Okay, this is the f function. Again, this is the function of fxy. This is the f function. Okay, so we have the function was fxy is equal to x plus y to the third. So now f1 and 1, so we just have to calculate those. We will have 1 and so we have f0 and 1 is equal to 0 plus 1 to the third. So this one is just 1, okay? It's just 1 here. We have 1 parenthesis 0 plus 1 to the third parenthesis 0.05. And then here we will have 1 plus 0 times this one is just 0.05. And then we have our first approximation 0.05. y1 is equal to 1.05. That's our first one. The second one now, you can keep going. We can choose y2 is equal to, not choosing, but is a fact because of here. Because y, here, y2 is equal to y, just like I prove it to you. Where is that? Here. I prove it to you right now here. Here we have y x2, okay? x2 is equal to y naught plus 2h, okay? So x2 is equal to x naught plus 2h. Okay. We know x naught is equal to 0. So we end up having 0 plus 2 times h. H is 0.05. Okay. And then we can have here h2, let me calculate, 2 times 5 is 0, is 10, and then is just 0.1. Okay. x2 is 0.1. x2 is 0.1. That's the way you have to do it. So y2 now. y2 is y1 plus, and then the next one is fx1, and then y1, and then h. And if you look at y1 is, we did, okay, y1 is right here. This is y1. y1 is right here, okay? So y1 is 1.05 plus f1 and parentheses, use that function here. And you know x1 is here. This is x1 and y, because here x1, and now y1 is this one. Everybody got that one? Good. And then it's parentheses 0.0. Let me write it down here. Parentheses 0.05 plus 1.05 to the third. Okay? And then times h. H is 0.05. And then if you use your calculator, let me check. Is approximately equal to, give me 1 minute. It's approximately equal to 1.11. Yep, that's it. And do the next. Now you have y2 is equal to, just approximately, or just equal to, that's okay, 1.111. Okay, we have our second one. And our third one, the same thing. We will end up having x2 is equal to 0. Let me calculate x2. x2 is what? 0.1. That's x2. Yeah. Yes, 0.1. Okay. So now let's okay, we have y2 is right here. y2 is equal to 1.11. And then that's all we need for y3. So y3 now. y3 is our next step. y3 is y2 plus fx2 y2. Okay, and then you have h. And y2 is equal to 1.11 plus the function. The previous function was x plus y to the third. And x2 is 0.1 plus 1.111 to the third times 0.05. And then we can have the y3 at the end. Let me check. And keep going, 0.05. Okay, you will end up having for y3 1.18. Okay, so you have, that's the way you have to do it for approximation. That's the main point for that chapter. Okay, please review it and check the process. Soon, if you do it once, if you know the process, you should be good. Thank you, guys.